Hi, this is your host Swapnil Bhartiya and welcome to second day of KubeCon and CloudNativeCon here in Valencia, Spain. And today we have with us Sanjeev Mohan, your principal analyst at SanjMo. Sanjeev, first of all, it's great to have you on the show.
Thank you so much for inviting me.
I have been, of course, watching your, talks on the Cube and other, areas as well. So there are so many things I want to talk to you about. So first of all, it's great that you are here. So now we can talk. First of all, it's in person. So that's a different energy altogether. But before we get into all the, weeds of Kubernetes adoption, tell us a bit about yourself and the company itself.
That's great. Thank you so much. It's such a pleasure to be here in Valencia, Spain. I mean, I'm so glad we get to travel again after a gap of over 2 years. Up until last summer, I was a Gartner analyst. I was there for many years. I ran the agenda for data and analytics space, and it's such an amazing place. I learned a lot, networked a lot, and then last year in August, I decided to just go on my own, become independent, and now all of a sudden my world has exploded. So now I not only am an analyst. One day I'm an analyst. Next day I'm organizing an analyst day marketing event for a client. Then the following day I could be doing sales enablement, and then I could be talking to an investor about what's the market pulse about investing, and then I could be doing recruiting. So I get to basically work with much larger number of clients and do a variety of things. And that's my life these days.
Excellent. That's excellent. Incredible change from what you're doing and then doing your own thing. Now let's talk about where we are, KubeCon.
Right.
So first of all, tell me a bit about what kind of trends are you seeing in this space. First of all, the fact is that Kubernetes adoption is growing as usual, and the difference is that in early days, of course, with a lot of technologies, the early adopters are sometimes tech behemoths, who have all the tech know-how skills. They want to play with they don't mind getting their hands dirty. But now the Kubernetes adoption is also happening at a smaller scale companies also. It's more or less like Linux story. Everybody, the joke will be that my toaster runs on Kubernetes now. So which also means that the kind of challenges, problems, opportunities also change because, the company at larger scale has a different challenge versus smaller scale.
Correct.
We are seeing adoption of low code, no code because everybody wants to go get on the band. So in general, broader, what trends are you seeing in this space? So two things I want to look at. First of all, what is driving the adoption? And because of this adoption, what is happening with the rest of the industry?
So Swapnil, one thing that I want to clarify right off the bat, that I'm not in my home grounds. I am at my peak when I'm at a data and analytics event. Here, I am literally in the midst of developers, infrastructure people, DevOps, SREs. So I bring a very different perspective. Even at this conference, who are the companies that I'm visiting mostly? I'm going to mostly database companies that have big, large presence here. For example, DataStax, CockroachDB, Hazelcast, there are a whole bunch Enterprise DB. So what I'm seeing them do with Kubernetes is phenomenal. For example, if I were to deploy a database on hundreds of nodes, just a few years ago, it would take me days. What if a node went down and I had to reinstall it? Now what I'm seeing is extreme scale of databases provisioned literally within hours. How? You have a YAML file. In the YAML file, I mean, it's advanced to a point where we can truly do hybrid multi-cloud with on-prem and multiple cloud providers. How do I do it? I can have a YAML file and I can say provision 100 nodes in AWS, 100 nodes in Azure or GCP, 200 nodes on premises, and I can do all of that in a YAML file and I can let it run. If a node goes down, it auto heals and it auto starts. So this is how Kubernetes is really making our automating our deployments, management, monitoring. All of that is becoming a cinch these days.
You talked about databases initially when we were looking at Kubernetes, but more or less like stateless workflows. But now
Yes,
you're looking at
correct.
stateful workloads.
Yes.
So how have things changed there? Can you talk about that as well?
Because I'm representing the data and analytics space, so it's been an amazing journey for the data space. Data space has lagged application by years. If you look at DevOps, 10 years ago, applications adopted DevOps, domain-driven design, application, creating products all of these things have been around for a long time, but data is only now catching up to it. Same thing with Kubernetes. When Kubernetes first came out, it was meant for stateless workloads. So if a node went down, then Kubernetes would detect and it would restart that node. But if a data node goes down, that's a huge problem because that can corrupt your data and make it inconsistent. So asset compliance becomes a really, really important part of doing stateful management using Kubernetes. Now, we have it. And now the database vendors have wholeheartedly adopted it. How we're doing it through an operator. The operator understands what are the needs of the database. The operator has been written and optimized for that database provider. And it knows what is the most optimized and efficient way of delivering that service. So just one more thing I want to say is that there's a reason why data is behind applications. Because applications don't change very frequently. You write an application, you deploy it. Data changes every second. I could have data drift. I could have schema drift. My machine learning models could have a drift. So it's very key to understand what's going on in the data space as opposed to the application space. So data is much more dynamic. People's authorizations change. Compliance laws change. So we have to do data residency. There's a lot of extra rigor that data needs, which applications don't, or the infrastructure.
Not only just the data is changing, but the size also grows. Application size will remain same.
Correct.
And then also you will be putting data on a data lake or data warehouse. There is a whole debate going on which one is better.
Correct.
Plus, data itself has no value. You have to extract value from it.
Correct.
So can you also talk about, first of all, once again, it can be so many questions bundled together. So I'll throw it one by one. One is that where to put your data. I don't want to get into a debate of data warehouses versus data lakes versus whatever it is, but petabytes of data is there, but you have to analyze it, and then where do you analyze it also matters. So how is Kubernetes kind of helping with not only as the data is growing, but you should be able to deploy it faster and also most about extract value from it?
That's an excellent question. You know why? Not because of this debate, data warehouse versus data lake versus lake house. All that is for a different time. But it's interesting because Kubernetes plays a role in bringing up these databases, but there's a alternate thing that's happening these days, and that's called serverless. And in the serverless world, there is no Kubernetes. There is Kubernetes a lot, but it's abstracted from the end user. So the end user doesn't even care whether it's a data warehouse or a data lake and which cloud it is in. Data is now being accessed as an API, or actually as a product. So I have an API that says insert the data into a database, and the API goes somewhere into the ether, and magically it's there. Now when I want to retrieve that data, I can use SQL, or I can use Ruby, C, C++, C#, Python, whatever I want, and I can extract that data through an API. I don't even know where it's installed, that database is. I don't care whether Kubernetes is being used. What is interesting in this whole scenario, the provider is using Kubernetes to stand up my container and serve me that data. I, as an end user, don't see Kubernetes. It's hidden away from me. So we are seeing this like a dichotomy. There are large companies that are using Kubernetes to build their own databases, and then there are these companies that are using serverless APIs, and they don't even care as to what's the underlying engine.
We are like almost in the midst of 2021 or 2022. It's hard to say which year that is. Now we are getting out of COVID, so it's easier to know which year we are in. What kind of trends you are expecting to see that will grow with, or you're like, hey, we're hitting the peak, and these are the challenges that the community will face?
Very good question. So I'm seeing a lot of very interesting trends. One of them is in the space of observability. Observability is huge at KubeCon this week, but again, I present a different view. So the observability that's big down in the exhibit hall, I know you've been busy recording these videos, but when you get chance to go down, you'll see that all of these like Datadog, New Relics, all of these that do what's called observability data. What they're doing is they're doing log analytics. They're taking this data, Elastic is big in this space, taking that data and analyzing the logs. What I see as a big trend is the opposite, which is data observability. Data observability is understanding the life cycle of data. It is understanding things that I just mentioned, like data drift, but data quality. I expected X amount of data, but I got half of it. The context of data, performance of the resources, how many compute, how many Spark executors, worker nodes did I use, and why? Why is understanding the cost. So that data pipeline, that understanding, monitoring, and predicting the performance of the pipeline is what we call data observability. So it is opposite of observability data, which is more of log. The joke I have is that the data observability companies that I spend time with, they all want to be the data dogs of the world. So Datadog is like this, the marquee name. And the funny thing is Datadog does everything but data, even though data is in their name. And now, of course, when they listen to this, they'll be like, how dare you, data is what we do. But what I mean is, it's not like the data that I'm talking about, which is what is the meaning of customer ID versus quantity of goods sold and stuff like that. They're doing data which is logs and data. So that's a very big trend. The second big trend is in streaming. So streaming, either ingesting streaming data and doing anomaly detection or all kinds of analysis on streaming data directly, what like Confluent, KSQL, some of these things do. Now those capabilities are being adopted by everybody. So that's streaming ingestion of streaming data. Also, streaming data as an egress, what we call change data capture or CDC. So taking the data as it comes in and moving it into an analytical environment like a data lake. So streaming data is huge, data observability. The third thing is unstructured data, semi-structured and unstructured data. For the longest time, we built our catalogs, we've done a lot of development on structured data. But most of the data within an organization is not structured. It's in PDF files, it's in images and videos and all kinds of stuff. So now we are getting better at understanding, extracting that meaning, the entities out of this unstructured data, cataloging it, making it discoverable, and doing analysis on it.
Excellent. Since you brought up observability, I have a question for you, and which is like, I'm not a developer or DevOps, I'm an observer from outside.
Yes.
No pun intended. So as somebody who's observing from outside, when I look at observability, it's more about, to know what happened with the system and then analyze what happened. But what happened to the action part of it, to take an action? Learning what is happening is only half a problem.
Yes.
But
it's definitely my favorite topic. I've been saying this in some other forums that understanding what went wrong is like, okay, great. I mean, I know there was a breach, but what do I do with it? So I have a point of view that observability should become the master or the leader that orchestrates actions downstream. So by observing the data, I should be able to say that there's a data quality problem. Mr. Data Quality Product, go remediate it. Go fix the data quality problem. Then I send it to Airflow for orchestration. Then I say, okay, the next step is reporting or notification or whatever it may be. So observability space needs to become the master orchestrator of the pipeline. And then, and that's a very opposite thing of way of thinking, because people just think, observability is one of the many components, in my environment, but it actually becomes the orchestrator.
One more thing with observability, when I look at it, is like, of course, when you look at CNCF landscape, there are different projects. But when I look at it, that if you look at a business, they are simply trying to solve a specific problem for their customers. All those things are second. Yeah, they do have to do that for that app to run successfully, but it becomes complicated. In the end, what I want is that, hey, you know what? I developed an application, I wrote an application, I'm running it, I want it to run smoothly, whether it's security issue, whether it's bug, whether it's reliability. So, but we have broken things in observability is there, security is there, reliability is there. You use some jargons and things. But what is your overall perspective that what should be approached? You said, that observability should be the master, which should be driving everything.
The problem that we are running into is that we have micro-segmented our data and analytics architecture to a point where we just keep specializing. We keep slicing reverse ETL. That's a separate topic. Metrics layer, feature store. So the CIO or the end user is like, wait, I just need to deliver value to my business. I don't understand how many different products do I need. Observability is interesting because in observability, people could be only doing data quality, or they could be doing performance, or they could be doing cost. But the CIO also needs security and privacy. So they need to know that an S3 bucket was left open by mistake, and it needs to be fixed ASAP. So you see, this data belongs to EU, and only people in EU should be able to see it. So we have a problem actually where the stack is getting complicated. It's getting disaggregated or unbundled into multiple components, and we are expecting the CIO or some end user to understand how to bring it all together. And that's not going to happen. This is actually the reason why we are seeing an emergence of bundled software, an emergence where companies are saying, I just want to buy one product, maybe it does 80% of what I do, but it takes away all the overhead of stitching together different pieces.
Sometimes I feel that, with the whole DevOps movement, cloud native movement, we were going to break old silos. But, of course, those silos were different, but I do feel that we are kind of creating new silos, because silos is more about expertise,
A data lake is a silo.
Yeah, when I bring it up, sometimes people say, no, I don't look at silos, I look at federated, but even in that case, you see, they're trying to make them talk to each other, but there is, once again, a specialization. That's what we are trying to break with the whole DevOps, devs and ops, and then DevSecOps also come in. So do you think that, we are still, moving in the same direction like a fashion, and then we'll try to break these silos once again?
So, very interesting history of this transition of how architectures evolve. If you go back to the modern era of computing, we start with mainframes. Mainframes, everything was a silo. It was centralized. You had to buy a mainframe from IBM or Amdahl or some Hitachi or some of those companies at that time, and everything was in there. Then we got into the era of PCs. So we decentralized everything. Everyone had a PC. Then we put Windows and we centralized it because everybody had to use Windows. Then the internet came and we decentralized it with the internet. But then Snowflake came and said, no, just be on Snowflake, we'll solve all your problems. So we again centralized. Today, we are back in the era of being decentralized. So now we are talking about decentralized apps, decentralized architectures, Web3 is coming in, all the crypto and all of that, Hyperledger and all that. So we are again decentralizing, but it's a pendulum. It's going to shift. And at some point we will centralize again. It's just how our technology just shifts. So right now we are just in the era of inventing new stuff and adding more and more components to the stack.
Sanjeev, thank you so much for taking time out today and of course share your insights. And that was an incredible discussion, and I would love to have you back on the show, whether online or in person. But I really appreciate your time.
Thank you so much. I am so happy I met up with you at this conference, and I'm sure our paths will cross again. So thank you so much for inviting me. Appreciate it.